Ahoy Captain, and welcome to First Aid for a Sustainable Ship, a series in which we provide guidance on decarbonizing your vessel. And as you can see, today is going to be electrifying because we're going to take a tug and make it fully electric. That's right, we're going to take the Sparky from Damen as an inspiration, or maybe even an homage. This is actually a photo of the Sparky, the first electric tug provided by Damen to ports of Auckland in New Zealand, if I'm not mistaken. I wasn't there, but the photos are beautiful and we have some information on the vessel, how it operates. But basically what we're going to do is we're going to put a lot of batteries on a similar type tug and see how that can reduce emissions, what the costs are, etc. So in a nutshell, because I know you're busy, we call this case study Sparky McSparkspark. That's a mouthful, but well, decarbonizing should also be a little fun. So we see 100% carbon reduction tank to propeller or tank to wake. That means that the emissions at the vessel itself are of course fully zero, fully negated. How you get your electricity, well, I have something to say about that, but not in this case study. That has to be done on a case-by-case basis. So we're going to assume fully electrical, zero emissions at the vessel itself. The CAPEX, well, that's a doozy. We see a lot of variation. Naturally, it has to do with either retrofitting or new build as well. We're going to go in detail later on, but what I can say is that between 70 and 80% of the CAPEX in this case is due to the battery pack itself, the purchasing of the cells. And that means that, what else have we? Inverters, maybe switchboard modifications, the retrofitting and accommodating on board the vessel itself. They're all almost orders of magnitudes less, or one order of magnitude less than the battery pack. So most of the costs are due to the cells. The payback, well, that's actually in this case study pretty bad, I'd say. Well, I'm honest, I'm not sure if I would do this. I'm even not sure if I would do a retrofit to fully electric at all. Or maybe I would, because I love electric vessels, but a payback of 5 to 10 years, I wouldn't recommend it to any shipper. I do have, all the way in the end, a way to maybe bring it back even more, but that's only in Northwestern Europe, in which I know of some subsidies, incentivized schemes for fully electric vessels that could potentially bring it back to below 5 years, but that also has to be considered on a case-by-case basis. That being said, what we try to do here is to keep the tank volume equal. So we know that these tugs have about 70 to 80 cubic meters of fuel, and we try to have a similar volume of battery packs in order not to make too many accommodations to the vessel itself. It needs to fit. This will impact your operational profile tremendously. So that's it in a nutshell. Moving on to the case study itself, it's going to consist of two parts. We first have the online tool part. That's the freemium tool that we're going to fill in together all the way from the beginning. And then with the premium reporting part, that's usually the paid part, but you're going to get it for free, so that at least you have some sort of a guess on what you get when you pay for the premium report. And we're going to discuss mostly inputs and assumptions in the online tool, and then results and discussions in more in detail, or more details in the second part, but there's going to be some overlap. So if you're interested in one or the other part, feel free to skip along, if that's how you say it. And then finally, a few disclaimers, of course. The Decarbonizer, that's how we call the tool, a bit of the process itself, but decarbonizing your vessel, well, you have to understand it's only a model. We use this model and it works very well for supporting decision making, especially in terms of long-term strategic decision making on maritime sustainability. Should I use an electric vessel or not? What are the rules and regulations that are coming my way for this vessel type? How much would it cost me in the long term? Are there financing or leasing incentives available, etc.? But please be aware, it's only a model. That means that we are in a feasibility, maybe in pre-feasibility or concept design phase, but we're never gonna, never say never, but in the coming time we're not gonna approach a detailed design study. For some parts maybe, but then again, I'm not going in detail. The Decarbonizer is a model, so please bear that in mind when you see this video. Secondly, it's also constantly evolving. Previous video is probably different from this one and also the next one. We're constantly updating and changing the tool itself, but also tweaking a few of the parameters in the assumptions that we use. So the video or the tool that you see now might be different than the one that's currently online. Thirdly, well, I'm also only a human. We make mistakes. Probably there's going to be a mistake in this video as well. I tend to solve them on the fly. That not always works, but that's also one of the reasons that we always provide a consult with the premium reporting. It's decarbonization and sustainability is complex, I admit. I've been doing this for, well, not almost 10 years, but we're approaching 10 years, and I still learn something myself every day. So that's fine. We can make small mistakes as long as they're not too bad an error. But also, please bear with us when we make small mistakes. And then thirdly, let's see. There we go. This is an independent, fully independent report. We want and need to be independent in order to provide you with good advice. We don't get any money from Damen for this video or for the case study itself, or from a battery supplier. So what we convey here in terms of information is all either my personal opinion or view and what we see in the market, or the sustainable ships view. So let's dive into the tool first. See, part 1, the online tool. This is the link you can use to click, and that will take you to the Decarbonizer tool that anybody can use. Let's go. So here you see the Decarbonizer. Well, should not fully appear on your screen. If you go to our website, you see a lot of extra information. We've now only shown you the tool. Now press on play to get even more focus. It's quite big, I admit. That's fine, gives us the focus that we need to really focus on your vessel. So from top to bottom, what do we see here? Of course, first ship type and then install power. And if we go to ship type, all these options available. We use these to preload existing conditions. But I admit, not all ship types are in here. What we're gonna do in the future is we want to add subtypes for tankers with Aframax, etc., so that we even have better estimates of your vessel itself. Make life easier for you, but that's taking some time. It takes time. For now, we have to make do with these vessel types, and I know that tugs are inside port/coastal, so I'm gonna go for port coastal. Loading. A nice Sparky McSparkspark appears here. Total installed power, that's one of the most important parameters used throughout the Decarbonizer. That's actually quite tricky for electrical vessels, because usually your entire drivetrain changes, and that will lead to efficiency losses, gain different kinds of propellers, so you should have different kinds of etc. So that's a whole, well, it's maybe a maritime engineer's dream or nightmare, depending on how you look at it. For this vessel type, I know that it's approximately 3,804-ish kilowatts installed, so I'm just going to go for 3,000 at the moment, and we can always change this later, so change it according with the operational profile, which is maybe the third most important thing that we're gonna do. So then we're gonna click on decarbonize your vessel. Was that easy in reality? Again, from top to bottom, we have ship and operational profile. That's our starting point. Rules and regulations. How much do we actually need to decrease? Carbon reduction measure. So that's what we have here. Here we have our reduction measures, and on the right hand side we have our preferences on visualization. We have shore power options, prevent measures, and change measures. That's how we do it at sustainable ships, and that means that we can either reduce or prevent fuel combustion, or we can change fuel combustion. It's either one of those two. Shore power is actually special because it not only prevents the combustion of fuel, but it also changes your operational profile. So that's why we put it differently, and also because shore power, so many regulations apply to it. It's special, at least I hold it dear. Maybe in the future we can include it in prevent measure, but right now we just have it as is. The visualization and finance option do it later. So here we have all the different options for our port and coastal tug, and this episode we're going to go for full electric, even though it's by far the most expensive here, and I know why it says 26 million. That's a bit scary. I'm gonna show you that it's probably a lot less, but it all has to do with the profile YouTube. So fun stuff. Your payback days will usually roughly be this, from what I see with full electric, at least in the way we have it in our model now, and it mostly has to do with the bigger your fuel consumption, the higher your potential gain fully electrifying your vessel. In any case, you get a 100% reduced tank to wake ship. And here we also see some of the most important parameters that we use that I also want to highlight, and I'm gonna change the standard table to CAPEX, OPEX yearly. And there we see our payback rate. So we have a huge gap here. We need to pay a lot, and it's only gonna get us gains in maybe 10 or so. So what we either have to do is we need to decrease the battery pack that we purchase. We can do half a battery pack. That also, you see, that also already helps. 500 euros per kilowatt hour battery cell cost. I know for a fact it is very close to what you can get in the market. Of course, make it less. I wouldn't go less than 400. That's about the minimum that I've seen that you can get for marine grade batteries. You can always be a cowboy and go for land batteries or worse quality, but that's gonna go bad, I think, in the future, especially if you purchase them. Then I would recommend it. But 400 euros per kilowatt, that's really the bottom. And then you see the electricity price, 15 cents. That's quite low, actually. What we assuming here is that, especially if you have a tug, but Sparky itself is moored in always the same location. You have to make a power purchase agreement in order to make this work, because otherwise it's just too damn expensive. And also in the Netherlands, but in Northwestern Europe, there are incentives to get money back if you use the ship for electric propulsion. So you can actually get even less than 15 cents per kilowatt hour. I've seen 5 cents per kilowatt hour, but if you put the incentives on top of that, you can go to a negative value, even less than minus 0.05. Well, this is of course overdoing it, I know, but you see here that we have a lot of parameters to play with. It is possible, but you're gonna have to do extra. We're gonna leave it at 0.15. We're gonna leave this at 500, and here we see the first error of the day. This one is 0.5, but it's rounded to ones. So, but we're gonna change this all in the reporting later. What else can you do? You have here your fuel parameters. Maybe the fuel, this one is still pretty high. Fuel price is lower at the moment, and that will definitely impact your business case. There we go. Yeah, even with the better assumptions here, we're still gonna see quite a long payback rate. A carbon tax included, yeah, that's slightly included, but I'm not sure if this vessel is gonna be paying carbon tax in the future, so we leave it at 0. Cool. Yeah, then this is never good. So this is why we make a model and not a fixed report, because you see, well, you change one assumption, everything goes out of the for clarity's sake, I'm gonna put it back to 85 roughly. This is all for different reduction. So here we have an OPEX breakdown. This one's important because usually it takes me quite some time to go through it together with ship owners, because you want to have roughly you want to have a good estimate of the fuel consumption you have per day or per year in order to get good estimates of whether or not this model really approaches reality. So here I have no clue if this approaches your vessel, because you're not sitting here and I am, but this seems rather high. Everything seems rather high, so what I'm gonna do is, before I do the CAPEX breakdown, that's be in the second part, I'm gonna go to ship and operational profile. Actually, we started at the end result, that's usually what I do, but this here, this beautiful little graph, the representative power demand, that's actually way more important than the outcome, you could say, because this determines your required battery pack. And here we see we have at the moment, I know for a fact, not very good approximation of the representative power demand for a tug. Usually, from what I see in the market, tugs are doing nothing for most of the time, which is perfect. And then for a short amount of time, very short amount of time, they're sailing to a specific location. And then they are, of course, using everything they have to provide bullet pool to guide the vessel in. So let's see what I put down in the Sparky McSparkspark case study. We're going to go for a combination. That means we're going to combine different operational profiles to do it. Operational profile, slide myself back to the bottom. We have roughly 300 days a year moored. That include nights, not just nights, during the day when the slide it properly go. And keep it as is. Then we have only a very small amount, about a week sailing. So this is per year, roughly. The case study later on. And about 3 months, 2 to 3 months working. Power demand is really high for 20 while idle moored. Power demand while sailing. For regular vessels, that's usually the highest power demand of all the operational profile. But now for tugs, it is not. The small boats of 400 is probably going to be a lot as well. This is where the magic happens. Another mistake, the 100s. Yeah. So this is roughly the power demand that we have, and the intermittent power here. I'm not sure. I'm going to go for 500 at the moment. Probably an hour. Probably 1500. This is an approximation. I'll show you what we have later. But we have doing nothing for most of the time, going to the job for some of the time, and doing the job for the rest of it. It's about our operation. These peaks could actually be higher. The peaks are not what concern me the most. Usually electrical equipment is very well equipped to handle peaks. It's about the energy that's required here. So that's really what floats my boat, speaking with ship owners. So once we're assuming now for a moment that this is correct. Here we have ship and fuel parameters. I'm going to go through them later, because this are Sparky McSparkspark. Everything else needs to be done correctly. Here in the engine characteristics, that's also pretty important. In order to provide an estimate of the fuel consumption, we have an estimate of the specific fuel consumption curve, as you can see here, which we base on the different engine types. Pretty sure that for these types of vessels, 4-stroke, main engine speed high, not so sure, but in any case, the curve itself won't change much. Again, these are all estimates and modeling. If you have your specific fuel curve, that would help us greatly, but usually we assume about 180 grams per kilowatt hour at optimum efficiency for diesels. You can see here, and especially when you're in a lower regime, that's where electrification and hybrid or battery pack will help you the most. But for a lot of vessels, when you're sitting here, won't do much. We can always decrease or increase efficiency of your fuel curve. So if we change this one, increase. If we up this one, we decrease. But this is something that we... Going back to rules and regulations, second last part. Here we have our rules and regulation timeline. I have to admit, for tugs, I'm not sure. I'm pretty sure this one doesn't apply, because for most tugs you're going to be well below 500 GTs. Actually 5,000 is what IMO does for the most part. But in Northwestern Europe, if we're going to include energy major to, that's to say, but at least 2 and 3, then you're going to see that also for ports and other local authorities, there's a lot of organizations that want to have you carbon neutral or zero emissions by 2040ish, 2030. Shore power is required in the US, which we're also working on the Clean Shipping Act, which requires zero in 40. Not sure if that's going to work, but anyways, for tugs, even though in the long term it might not be that much of a requirement, but it's hard to say. But in 20 years you're probably going to need a zero emission tug anyways. But here you can read up on all the different rules and regulations. You can click here further to get to our website with more information. What we're going to discuss in more detail at the end is HBE in the Netherlands to provide you with the economic incentives to make this work better. So one final thing to say, once we have, as you can see, well, we have a similar profile as the one we had just before. We still have a lot of money, 4 million. Well, like I said, between, what did I say, 3 to 6 million. That's usually what I end up here with tugs. The CAPEX breakdown we're going to leave for the second part. There's one thing we can discuss, and that's purchase versus lease rental. If you lease it, then you'll notice that, or what we assume here, fully correct. What we assume is that the entire sum of 4 million, in this case euros, will be leased, so you don't have that cash out, and you pay additional for your OPEX. To OPEX breakdown here, we have 0 lease and rental, but it's rental 1,200 euros a day, but then we still have some savings, and this, I think, for electrification would always be my recommendation. At the moment, a battery cell tech rapidly evolving, even faster than our Decarbonizer, but innovations are amazing, so there's a lot of gains to be had there. And then secondly, there's something to be said to not have 4 million cash out. I think these vessels they cost a lot less than that kind of money, so there is something to be said for leasing or renting it out. So once you're happy with implementing all the information, you can put in your email address here, and then your personal Hotmail, that's very retro. You can send get PDF, there we go. That will notify us that you have a question. Here I see we also need to change a few values. And with that underway, we can give you a more detailed reporting. So that was it for part 1. Let's continue on to part 2. Onwards and upwards to part 2, the premium reporting. So this is usually the paid part, but you're gonna get lucky in case you're looking into electrifying your tug. Here we have a link to everything that we have posted online. Clicks, yep, verification. So this is actually everything that's on the website, and here you can see you can download the report. We have already pre-inputted the tool. We have some ship type considerations and technology considerations that we're gonna go through together with you. And if you click here on download reports, there we go. This is the report that we're gonna discuss together, but I'm gonna treat you to something very special. We're going to look into the back end of this report. We're gonna change some parameters on the fly to give you another insight into how things will impact your vessel design. So let's go to the back end. So here we have the report in this fetal form. This is when we are discussing all the ins and outs and taking your input parameters. As you can see, there's you can recognize design from the report that we just saw. And here we have the executive summary with your operational profile, main rules and regulations, and the decarbonization measures. And here we have a table and all the rest. And we're gonna quickly go through the executive summary before moving onwards. Here's the first thing that we might want to have a look at later on. As you can see, 3,879 kilowatt max, that is this peak, although these peaks won't impact your cost that much, maybe your inverter design, etc. It's mostly about the energy content when it comes to full electrification, but still way too high for, especially for this small bugger here. The Sparky is normally, or Sparky McSparkspark is a lot bigger, but we don't have all the drawings yet. In any case, we have about 7 megawatt hours of daily energy, and that is a lot electrical or battery supply. 7 megawatt hours, well, I know for a fact that you have about 1 megawatt hour per 10 feet container commercially available. You can go a lot more. You can maybe go about twice as energy dense if you really want to, but then you're reaching a limit. So that's gonna give you about 7, in this case what we have here, about 7 10 feet containers of volume, which is still doable. That's actually close to what this tug has in terms of regular fossil fuel tank volume, but it's gonna be tight. Then the CI and EXI on this type are not applicable. It applies to EU ETS as well. I'm pretty sure that these ones are not going to be incorporated. So in this particular design, we have included them, but maybe we'll remove it later to see how it influences. And then finally, here we have it's a bit curved, but a nice line up until 2040 zero emission. Also here, I'm not 100% sure. Well, I mean, it's sometimes hard to determine what we do next week, but 2040, I'm pretty sure this line is quite steep. Then again, I know for a fact that some local authorities, especially in Northwestern Europe, outside Northwestern Europe, I'm not so sure, or I'm pretty sure that it's less. They're gonna aim for sooner than 2040 zero emissions. So we're just gonna state 100% reduction. At the moment you're fully electrified or only have batteries, then of course you need to have a look at where your electricity comes from. But in terms of all rules and regulations, you're going to comply with all of them. All the known, upcoming and existing rules and regulations are very well accommodating for full electric. And we just had about 4 million in the tool. As you can see, there's a lot of variance. Right now we're at about 6 million, still with I think a little bit less delta OPEX or day rate increase than we have. We're still left with a payback rate of about almost 10 years. So even with my bias for electrification and my love for batteries, I'd say that I wouldn't even do this. I would have to improve the business case substantially. Yeah. All right. So moving onwards, table of contents. Well, we're gonna go through them in a bit, of course, but we have our operational profile. That's pretty important. Key upcoming rules and regulations. We've discussed that for the most part. Carbon reduction measures. That's, of course, the part where the magic happens. Everything else for this tug, considering CI, EXI, and EU ETS are less relevant. we could skip that, and these are simply case studies for your references only. The input values and assumptions we're going to discuss while we go through the report. The disclaimers we have discussed, keep in mind we are only humans, we make small mistakes. Here the operational profile, so let's dive in. We have assumed tugboat, port coastal, diesel, 3,804 kilowatt hours of installed power, even though I'm pretty sure it's a lot for this kind of vessel. I'm pretty sure it's a lot. We don't need 4 megawatts to do all the work, but then again, who am I to decide that for you? So we're just gonna leave that in, and basically what this does, it does two things. It determines, together with your operational profile that's below, the energy content that you need to bring with you, and secondly, the cost for inverters, drives, electrical equipment, breakers, etc. Although these costs will be about 1 order of magnitude less than the battery packs. I focus on the battery pack. The auxiliary engines, quite small, about 100 kilowatts, and even then, these are big. Let's see what else is important. Well, I'd say basically that's it. Our area Europe, that's important, because outside of Europe, or maybe in the US or some other places where you have very cheap electricity available, I would recommend fully electrifying your tug. Then again, I'm not sure if I would recommend retrofitting, but and here we see the operational profile, or here actually most of the time it's doing nothing, 300 days a year, then it's doing a little bit of sailing, about a week a year, this consecutively, and then the rest is working. So this does include weekends, etc., and I'm assuming a port tug like this is on standby for most of the time. And that's good, actually, for our case. So here we have the different operational profiles that we have for each profile, and the average or the combination is actually, especially in this case, very hard to really determine, because you want to have an average day, and what we do here is we average out over the year because of mostly CII requirements, but it's really important to dive into specific use cases to make sure that you can do what you want in terms of operations with the tug. And we're going to consider the length of your operation later and how that affects your design and cost. But here at least we have a nice breakdown of idle moors, what you need, sailing, what you need, and working, what you need. And then you can together with us determine how long you need to sail before recharging, in this case, how long you can work before recharging, etc. So the Sparky, the Damen Sparky itself, it states that it can operate about, or it can do about 2 operations before it needs recharging at 1.4 megawatt recharging, and then it's recharged within 2 hours. So it has a battery pack of roughly 2800 kilowatt hours, and we're going to see that battery pack, actually what we have here, is a lot more. So take that for what it's worth. Here we have some more graphs on the different operational profiles, and here you can also see these graphs usually guide me as well. If this is the average of your engine, well, anything below 30%, I'd say electrify that beauty, because anything below 30%, you either want to have full electric or hybrid mode. That is something we're going to see in the future. But if we are sailing, or let's see, here. This is, I think, another mistake, because it should be, no, I know what happens here. 400 kilowatts, and that's because we only have one single engine at the moment in our model. So we know that they do not, these types of tugs, and I've assumed, big assumption here, don't use as much power for sailing. They use most of their power when they're just propelling the vessels to port or doing their port stuff. And here we see that actually at that point, most of the time, we're still maybe not fully loading our engine, only at the peaks, but on average we use a lot less of the engine power that's available. So I have to say I've never been on one of these vessels while we're sailing or working, so also take that for what it's worth. This is something that we do together with the ship owner, with you. But at least now you see what we have put in as assumptions, and once we have better assumptions, and also the fuel consumption fits more to your specific operational profile, then we can really assure that we have a representative power demand. Here we have the key rules and regulations. Like I said, most of them we have discussed, especially if you're working for some clients, ports or shipping companies that have 2040 or earlier as a target date for zero emissions. Then I would recommend something like this. But apart from that, outside of Northwestern Europe, this is probably, it's always cool to have an electric tug, but man, it's expensive, and it's hopefully prices will decrease. I'm pretty sure that prices for batteries, at least on land, are and will decrease further, but it might take quite some time before that trickles down to the maritime industry. So there's one thing we can discuss later on in the business case, and that's HBEs in the Netherlands. That's renewable energy unit. I'm not sure if that's the correct translation, but in any case, if you electrify a vehicle or something that transports itself in the Netherlands, you can get 4 to 20 cents per kilowatt hour back funded. It is quite an elaborative incentive scheme, and it has to do with replacing fossil fuels with green energy, or at least electricity or something that's less polluting, and that can greatly benefit your business case here. And EU ETS, in this case, we have about 180,000 euros worth of carbon tax. Well, I haven't really looked at it that way, but that's also quite expensive, but most likely we don't need. So, full electric, as you can see here. A lot of times it's one of the most expensive options, apart from hydrogen, and you do see quite some returns, usually. The returns you have are also, of course, based on the current fuel price and the electricity price that you provide, but still, because you also have no engine maintenance, or you do have some maintenance, but in general, the maintenance for your battery pack and your electrical equipment is a lot less than the maintenance cost for your engines. That's going to greatly improve the business. So here we have the selected measures. In this case, we're only going to look at full electric, but we can make a combination of different options in order to get exactly the right order or the right menu for you for decarbonization. We have a lot to choose from, and that we do together. So up and onwards to the good parts. Here we go. These are just some simple schematic, diagrammatic overviews. We do have a table with most important information for you to consider. And you could use this, for example, to go to a supplier to discuss, okay, this is the order of magnitude of the system that we need. Please provide us a budget quote, and then compare it with this one. And here we have some more information. The case itself, another vessel that's a bit larger, but also electrified, also autonomous. That's cool. And here we have a schematic of what we are doing in this particular scenario. So I'm going to highlight already the things that we are or might be doing wrong. So if we have the Sparky here, if we are retrofitting a tug such as this, I'm not sure if your switchboard or your main electrical equipment is able to handle the DC power that's coming from your battery pack. What I've done here is I've assumed a DC bus bar on which we put 690 volts battery pack. Usually they operate at 690 volts, or roughly that order of magnitude. Our battery pack here is about 7 megawatt hours, which is more than twice as much as is installed here on the Sparky. That's also where most of our costs come from. I can change that later. That powers the propulsion, the hotel load, and also the shore power supply. That's coming from, of course, shore, and that will need a converter to DC in order to charge the battery. So what I've done is I've assumed that's not a big of an issue, which it probably is. So that's why I'm saying retrofitting a vessel such as this. One, it needs to be diesel and electric, otherwise you're better off buying a new or purchasing a new vessel. Secondly, there's probably going to be some switchboard modifications, if not also propulsion modifications to be made, because if these are not DC engines, you're going to need an inverter there as well, which is, well, most of the time the case. Anyway, so this is roughly the schematic, but given all these exemptions, assumptions, errors, etc., we can also make it very easy for you. You want to have a DC bus bar, you apply a battery pack to it, you're going to need a converter for charging, and everything else that depends on the equipment that you have installed on board. So we go through it together and see how that will influence your cost, because we go to the left, and I'm also going to go to another screen here, because then I can maybe change some parameters. We are now assuming there is a spare breaker or switchboard available, so modifications on the switchboard is little to negligible, and we also have a converter and transformer. Well, transformer might not be, but in terms of cost, we're going to assume transformer as well for shore power supply. That's not stated there, but right now we have assumed a lot of extra cost, and in the cost part later on we're gonna see how that influences our total CAPEX, because you're gonna see that most of it is influenced by the battery pack itself. So that's what you want to focus on. So shore power in this case, and we're probably going to change that later. I mean, what's shore power when your vessel is fully electrified? You're going to need a pretty big charging station, so you can consider that shore powered, but this is going to be removed. We're going to assume at the moment 1 day of electric sailing or operating. Nominal power per trip 19,250 kilowatts. So these trips, and energy consumption per trip 6,093 kilowatt hours per day. That is something that is the most important part, as we saw. And how come then we have 7,000 kilowatt hours required per day, but a battery pack that's a lot bigger? Because you cannot fully deplete your battery pack. You need to have, we have assumed at least 20% left over, and charges up to 100%. So that's our state of charge high and state of charge low. But maybe the battery supply can provide you with better assumptions there and decrease cost. Like I said, we have assumed very energy dense battery packs. I just say that 2 megawatt hours per 10 feet container is max, so 2.5 megawatt hours per 20 feet container, that's doable. Then again, we can maybe put the battery pack inside the vessel, but we still need a lot of fire protection depending on the cell chemistry. So 2.5 megawatt hours per 20 feet container, that's a good estimate of the entire system, including some fire suppression and cooling systems, because what I've seen in the market is you can combine the single 20 feet container. That means that the minimum volume required per day is 81 cubic meters per day, and like I said in the beginning, we want to have a similar tank volume, so that's roughly what we're aiming for. So I've also did it in such a way that we can cram as much energy in it as reasonably possible. Operating voltage, distance to engine room, etc. That has to do with the cabling, but mostly the cost. Also in this case, that's not going to impact much of your total CAPEX. So that's it in a nutshell of the system that we have here. And if you want to learn more, you can click on learn more about full electric. Then you go to our insights page, and here we have some case studies for you to have a look at if you're interested. Now on to the funnest part, or maybe the most important part for you as a ship owner. There we go. So here we have a very nice pie chart, of which big part of the pie is dark blue, and it has to do with equipment procurement. So why is most of it so expensive in terms of equipment procurement? Well, that has to do with one thing and one thing only, and that is of course your battery capacity. So I'm going to show it here. So we have 7,617 kilowatt hours of estimated capacity, and if I'm going to override it to the same capacity that the Sparky has, then you're going to see prices are slashed almost in half, at least for the battery pack itself. So we went from a total of 3,380 blah 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 to 5,649. So I'm going to look at equipment procurement cost only. And so if I see, and here to the right hand side, this is our table breakdown of everything that we consider, and that's all linked to the operational input parameters that we provide. And if you have a battery system here, so right now we have the full, so the twice as big battery pack as the Sparky 3808. So that's almost 4 million. And if we change that back to 2800, yeah, that's gonna slash that in half. So that's linear. You pay a price per cell, per kilowatt hours, and we are assuming 500 euros per kilowatt hours, which is, well, you can get a little bit less, but not more. So this is, I wouldn't say rock bottom prices, assuming they're gonna go down, but that's what's, that's the most important part in this entire case study. So halving your battery pack will also greatly decrease the price. That being said, other cost components include switchboard modifications where needed, breakers, etc. So this is something that when I'm sitting with you as a ship owner, we're going to go into detail, maybe have a look at further. But as you can see, these costs combined, yes, they will be about as much as the entire battery cell, but that all depends on how much time you want to sail with it. If you want to have twice as much sailing time, then your well, your cost gonna go up, gonna double. That's the word I was. Okay, So here you can see all the other things that we take into account. Then again, execution, retrofitting, commissioning. I have not looked into detail in this case study because simply the fact that this is so expensive, why bother with the rest if you want to focus on your electrical equipment. So that's it with regards to the cost. Maybe one thing that we can consider at this point is the OPEX and of course the payback rate. Yeah, here we see, here ETS cost luckily is not included. So at this point we haven't included ETS cost. Maybe that's a small mistake from our side, but this should be, this should be correct. At least here we have a conservative estimate, and it will also, we can see here, even though we have a 64% decrease in operational expenditure, so your day rate will decrease 60%, perhaps even more. If you do have to pay for carbon tax, you have to invest a lot of money, like millions. So that's what I see, not just in a lot of case studies on the internet, but also what I see commercially is that you pay a lot of additional cost for a greatly reduced day rate, but that does not always outweigh the benefit. That's it. We have a lot of potential suppliers that we can connect you with. That all depends on your preferences. Our preferred partner in all matters regarding electrification is Cone, but we can also recommend you to other partners if needed. And that's that's not it. The input parameters we have discussed for the most part, and in this case, most importantly is I think your fuel price before and after change, fuel price, the fossil fuel price. Here we see euros per liter. That is a small error. That should be euros per kilowatt hours, the same as here. But in any case, what we see is that this case study is very much dependent on two matters, and that is the fuel price, before and after, but mostly the electricity price you pay when charging. So you need a power purchase agreement, and in Northwestern Europe, Netherlands, we can recommend the use of HBEs, which will greatly improve your business case, perhaps make that price even negative so you get money. And then secondly, it's all about the battery pack cell, so the price per kilowatt hour for your batteries. Those are the two main parameters for this case study. And that concludes our first aid for a sustainable ship case study for our great beloved little friend Sparky McSparkspark. As you noticed maybe at the end that I was going very fast because I get so excited with these kind of things. It's really enthusiastic. Again, I get really enthusiastic speaking about decarbonizing vessels, but with regards to this particular case, my personal recommendation, I have a lot of them to make, but I think the question here is to ask yourself, why would you do this? If you do not have either a client, very strict rules or regulations, or extreme intrinsic motivation to do it yourself, then I wouldn't recommend to do it. I wouldn't recommend at all to retrofit a vessel to a fully electric vessel in the first place. Usually I would recommend purchasing a new electric vessel and then reselling your previous vessel. But I mean, it also depends on your crew, what you want, and to what extent other factors come into play. For this vessel, I would certainly recommend to look into a lease option, especially when you consider the battery lifetime. Usually they should last for 10 to 30 years, but then again, it's hard to tell because a lot of marine batteries haven't been tested for that long. So when you lease your vessel, you do not have that risk. And finally, what else is there to say? Maybe the fact that we're going to revisit this particular case study in the future, see if we can compare it to not full electrification, but hybridization. That means using a battery pack for something in between spinning reserve and load leveling, and that might give you other options to consider when you want to electrify or electrify the tug. I mean, reducing carbon emissions on board your vessel. This has been it. Thanks for watching this case study. Please feel free to contact us by using the help desk. Just click on the button on the website, and I wish you all a very great day.